let's do number 13 on page 238. It's about a sliding ladder. A 13-foot ladder is leaning against a house. When its base starts to slide away, by the time the base is 12 feet from the house, the base is moving at a rate of 5 feet per second. How fast is the top of the ladder sliding down the wall at that moment? So, you've got a wall. It's number 13, lesson 4-6, page 238. You've got a wall that's straight up and down. You've got a floor we're assuming is straight horizontal. So you've got a right angle here. You've got a ladder. The ladder is 13 feet long. So it's not a ladder that's changing sizes. This is always going to be 13 feet. So we don't need a variable there because that's going to be 13 feet no matter where that ladder's at. Okay, the ladder's not going to get shorter and longer. What's happening is the bottom of this ladder is kicking out and going this direction. You're up here painting, you're coming down, right? Falling down the ladder probably, like this. All right? If we call this y, and we call this x, if the ladder's coming down, what do we know about dy over dt? It's negative, yep. So dy over dt is going to be negative because y is decreasing. X is, the bottom of the ladder is kicking out this way. So what do we know about dx dt? It's positive. X is an increasing value. So dx dt, that's change in x divided by the change in time, is going to be a positive value. How fast is the top of the ladder sliding down the wall at that moment? So they want to know dy dt. How fast is the top? So if you were standing on the ladder, how far would you be going towards the ground? In other words. Okay? Now they kind of give you this one instant in time that they want you to analyze. That one instant in time is when the base is 12 feet from the house. So this is 13. The base is 12 feet from the house. At that one instant, how fast is the ladder moving downward? Okay? So first of all, how could I find y? Pythagorean theorem, yes? So 12 squared plus y squared equals 13 squared. Or if you happen to know some of your common right triangles, you might know this answer from geometry. So let's go ahead and work it out. 144 plus y squared equals 169. Subtract 144 off both sides. Y squared equals 25. So what's y going to equal? 5. So y will equal 5 feet. All right? If we're going to try to find how fast the top of the ladder is dropping, what do we have to do with these, the x and the y and the 13? Right, the Pythagorean theorem. So I'm going to go x squared plus y squared equals 13 squared. What's the next step? Derivative with respect to time. So the derivative of x squared is 2x times dx over dt. Remember, you're really doing the chain rule. You're multiplying by 2 out front. You're taking that down to the first power. You're copying down your x. Then you're multiplying by the derivative of x with respect to time. What's the derivative of y squared with respect to time?
2y times dy dt.
Good. 2y times dy dt. 13 squared, that's 169. What's the derivative of 169?
0.
0. Good. All right, let's start plugging in some numbers. Let's plug in 12 for x. So 2 times 12. dx dt. Do they give us a dx dt?
Yeah.
Yep, it says the base is moving at a rate of 5 feet per second. So you want to make sure you make a decision whether that's positive or negative. What did we say? If the base is kicking out, x is getting larger, so this would be positive or negative? Positive, right? If x is getting larger, then the rate of change of x is positive. So dx dt is going to be 5 feet per second. For y, we're going to plug in 5 feet. dx dy dt is what we're trying to find. So 2 times 12 times 5 is 120. 2 times 5 would be 10 dy dt equals 0. What's the next step? Subtract 120 off both sides. So you get 10 dy dt equals negative 120. Divide by 10 on both sides. dy over dt equals negative 120 divided by 10, which is negative 12. What would be the label on that? Feet per second. The negative means the ladder, the top of the ladder is dropping towards the ground, dropping at 12 feet per second. Any questions about that? Okay, let's go to part B. At what rate is the area of the triangle formed by the ladder, wall, and ground changing at that moment? So now they want to know how fast the area is changing. So you're going to do dA dt. So if you want to know about the area, we have to write an equation for the area. So, equation for the area of this triangle. How would you find the area of a triangle if the base is x and the height is y? Remember the what's the formula for the area of a triangle?
Base times height times y.
What, 1/2 times the base times the height. Okay, so 1/2 times x times y. That's the area of a triangle. 1/2 base times height. 1/2 x times y. Let's do the derivative. Derivative of a would be dA over dt. What rule am I going to have to use because of the fact that it's just multiplication right here? Product rule. So let's like 1/2 x be our first expression and y be our second expression. So product rule says you take your first expression, which is 1/2 x, times the derivative of your second. How would I write the derivative of y? Good. dy over dt plus your second expression, which is y, times the derivative of 1/2 x. Good. 1/2, and then times the derivative of x, which would be dx dt. Now I think we're talking about the same instant in time. Let's make sure. At what rate is the area of the triangle formed by the ladder, wall, and ground at that moment? Yep, so we're going to use the same moment, the same instant. So we're going to plug in x, we're going to plug in 12. dy dt we know from the last problem, right? dy dt is negative 12, that's from part A. Y we know was 5 feet at that instance. And for dx dt we know is 5. Right, 5 feet per second. So 12 times negative 12 is negative 144, half of that's negative 72, plus 5 times 5 is 25, half of that's 12.5. So dA dt equals, what would that come out to? Right, negative 59.5. Now let's think about what the label would be on that, because it's a change in area over a change in time. If our distances are in feet and our times are in seconds, what do you think the area would be in? Feet squared. Right. Good. Square feet per second. Square feet because it's the change in area. So as the ladder is sliding down the wall, the area of this triangle at the one instant when y is 5 and x is 12, at that one instant, this area is decreasing, because it's negative, decreasing by 59.5 square feet every second. Any questions about that? All right, one more, part C. I'm going to erase part of this so we can do part C and then we'll be done with this problem. Part C is a little bit trickier because now we're going to talk about an angle. Part C says, at what rate is the angle theta between the ladder and the ground changing at that moment? So now we're talking about the angle between the ladder, which is right here, and the ground, theta. Okay? How fast is that angle changing? Right, as the ladder goes down, as this ladder is sliding and going down, this angle is going to be changing. This angle right in here would be changing. How fast is it changing? Okay. What type of label do you think we're going to have on that? Degrees per second, or it could be radians per second, either one. Okay, depending if we're doing this in degrees or radians. But all right. Let's go ahead and write an equation that involves theta. This is y. This is x. We know this ladder's 13 feet long. okay? There's different ways you could do this because we have our trig rule, SOHCAHTOA. This is a quick review of trig. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. So you really have three different options of equations you could write that involve this angle. So you could go sine of theta equals opposite over hypotenuse, so y over 13. Or you could do cosine of theta equals adjacent over hypotenuse, which would be x over 13. Or you could do tangent of theta equals opposite over adjacent, y over x. So you really have three choices, okay? I'm looking at my notes because I want to make sure we pick the easiest one. And maybe there are different ways to do them actually, but let's go ahead and do it with tangent, okay? Tangent of theta equals y over x. So I chose this one. Probably could be done other ways too. Sure it could be. All right, let's do the derivative. What's the derivative of tangent?
Secant squared.
All right, so you have secant squared of theta times, what do you think you have to put on after that?
Oh,
Chain rule says you have to do the derivative of your variable too, yeah?
so theta prime.
Close, we're doing it with respect to time though. Did you say
Oh, theta over
Theta.
d
d theta over dt, correct. Equals, on the right side we've got y over x. What rule do you think we're going to have to use there? Quotient rule. So low d high minus high d low over low squared. So low d high would be x times, how would I write d high, the derivative of the top?
dy over dt.
dy over dt, good. Minus high, which is y. D low would be dx over dt. Over low squared, it should be x squared. Now let's start plugging in some numbers. We know from our past examples that x is 12 and y is 5. So we can put a 12 in for x, a 5 in for y. We know dy over dt for part A. What was that? Negative 12, yeah. We know dx dt, what was that? It's given in the problem. 5 feet per second. X is 12, so you have a 12 squared down here. Now, the one thing that might cause you problems is secant squared of theta. Well, we can go back to our picture, and we can figure out what the secant of theta equals. Okay, because we have this picture. At our one instant in time, we know that y is 5, x is 12, and our hypotenuse is 13. Our secant of theta, cosine is adjacent over hypotenuse. Secant's the reciprocal of that. So I do hypotenuse over adjacent. So it'd be what over what? 13 over 12. Yep. Cosine would be, again, cosine's adjacent over hypotenuse. So cosine would be 12 over 13. So secant's going to be 13 over 12. So that's what I'm going to plug in here for secant of theta, and then it's squared. So let's work this out a little bit. If you square 13 over 12, you get 169 over 144 times d theta over dt. On the right side, we get negative 144 minus 25, so that's negative 169 over 12 squared, which is 144. What would I do to both sides now to solve that? If I want to get rid of this fraction on the left, how can I get rid of that? Multiply by the reciprocal, which would be 144 over 169 on both sides. Cancel, cancel. D theta over dt equals, what's that right side come out to? Negative 1, yep, so negative 1. And we're doing this in radians, this would be radians per second. So this angle, at the moment in time that we're looking at, this angle is decreasing at 1 radian per second.
What, how do we know it's radians?
If it's not given, if degrees isn't given, assume radians.
Okay.
Okay. Any other questions?